Okay, I guess we'll get started. Hi everyone, I'm Veda Shankar. I work for Red Hat. I'm a product manager in the, in the application developer business unit. The product that I'm working on, it's a suite of, products under the trusted software supply chain. But we'll talk about the upstream projects that we work with. And to kind of set some context, we'll basically, cybersecurity attacks are become so commonplace that unless you have something with of a real global scale, like the SolarWinds and Kaseya's and Log4j, it doesn't even make it to the headlines. So why are there so many, hacking events and vulnerabilities that are happening? And one of the reasons is that the attackers have found a new vector, right, with which they are able to execute malicious code, and that is your software supply chain. And so your traditional perimeter defenses, your firewalls, all those intrusion detections, they're on the periphery, but with the typical software supply chain attack, it is coming from the inside. It is a user, a developer who is pulling down a library or a source code that has the malicious code and is now within the system, so is not detected unless it just spreads. And also, one of the reasons is we are more and more dependent on open source, right? So you cannot build an application today without open source. And so open source actually, we are setting some baseline, talking about vulnerabilities and, supply chain is one of the main, areas of attack. And also one of the reasons is a lot of open source components, right? And so if as an enterprise, you have to use open source, but if you want to use open source, you want to make sure that the libraries that you're using are actually, the community behind it is active, right? And there's you want to make sure that it is reputable. They are following, it is not end of life, and so those are pretty critical, because when you look at some of these stats, it says 90%. There's been no activity. So you really need to know when you're pulling down these open source libraries, whether it can be trusted, right? And so, and now governments are also with all these occurring incidents, there is legislation. Actually, it's world over, not only the US, EU is on it. I was in Australia and same thing, So they are requiring, especially with, they have directives where basically they're saying that, hey, if you are going to be consuming, if you are a software vendor and you want to supply to the agencies, then you better provide, bill of materials. You better have a secure process by which you're delivering the software, and you're going to be also liable. And so it's going to get more and more stringent. In Asia Pacific, for example, you cannot deploy a container image unless it has been signed. So, these requirements from the government agencies are going to get tougher, and it's going to come with some severe penalties, because the consequence, as we have seen with SolarWinds and all that, has been pretty bad. So if you kind of summarize what are the asks, right? It's basically, if you are a creator of software products, then you better make sure that it accompanies software bombs, right? Software bill of materials. Make sure that even as if you are producing, you create SBOMs, and it is better to do this right at the build time, so that way you're more proactive about taking care of security vulnerabilities right at the upfront. Also, regular updates and patching. As soon as there are security patches, you need to apply them. Of course, dependency management, which with software composition analysis. This is something that a lot of folks are already doing today. But one of the areas that is not being done is like basically sign everything, right? Sign everything and verify everything. And so that's where we'll talk about it. We'll talk about Sigstore. That's one of the recommendations, and it's part of the open software, secure foundations. And also like scan all artifacts, scan it at every stage, right, throughout your supply chain. And also like, in order to make sure that all this kind of happens in an automated way, because if it is manual, then we will not be doing it, right? And it's going to be time consuming. So how do you automate it? And so policy as code. And we'll talk about another upstream project called Enterprise Contract that helps you to enforce SALSA. Who knows what is SALSA? Sorry? Did you? Okay. Yeah. So SALSA actually stands for Supply Chain Levels for Software Artifacts. So basically, this is something that you'll start hearing, and they'll say, hey, are you SALSA level 1, 2, 3, and 4, compliant? So basically, level 1 says, hey, if you are producing any software, then make sure that you have documented. So that's just the basic level 1, and level 2 is make sure that you have you know what build system it's being built on, what is the source that it is coming from, and so that is your level 2. Level 3 is kind of, is this auto-generated? So it is not like the person who is building is actually also creating this provenance. So when you build an artifact, it's how basically the cookie is made, or how is the artifact made, that is called as provenance, and you need to kind of create an attestation. That means you need to create a signed document based on how that artifact was created. So this, if it is automated and if the developer cannot change it, so that means there's an observer which actually creates this provenance information, then it is much more secure. And at the same time, of course, your build system itself has to be made secure, and so then you get to a higher level of SALSA, which is like SALSA level 3 and then level 4. So now you have some build systems like Tecton. How many of you use Tecton for your build pipelines? Anybody? Okay. How many use GitHub Actions? Okay, I see a few hands go up. So GitHub Action has a SALSA generator. So does Tecton. Tecton has Tecton chains. So these will automatically create the provenance information. For others, like if you're using Jenkins, GitLab, you can have a script. And of course, if your build system is secure, then at least you are better off than not having any provenance information. Okay. And of course, you need to also make sure that the packages that you're getting from your vendors also, it comes with SBOMs, it has signatures, and it has provenance information. Any questions so far? Okay. So what you see here is like you know, your typical your supply chain, you know, and it's a typical foundation model where you have the code, build, deploy, run / monitor, right? Now, as you can see, each phase of this supply chain actually is vulnerable, right? And so you need to basically protect. But what we see in the industry is pretty much everybody's doing some code scanning, you know, the static, you know, security testing, and also the dynamic security testing. And at the same time, folks have like things like admission controller, where they're making sure that the container image before it is admitted into their Kubernetes, you know, for running, it is being, yeah, come on in. Change the mind. Yeah, so you have things like admission controller, but what's missing is there are some gaps in this. And also, like, how do you make sure that the tools that you're using can be easily automated, right? So it's kind of cloud native, and it can easily be automated as part of your, you know, build pipelines. So we at Red Hat, we have started, you know, also kind of improving our own build pipelines last few years, and we found that these tools are actually quite useful, kind of to address those gaps. So the first one is making sure that every time you create an artifact, that you are signing it, and then at every subsequent step, you're also verifying it, right? And then also, at the same time, when you're building an artifact, make sure that it creates a build provenance, and you're again creating attestations by signing that the build provenance, and and also make sure that it's enforced before you promote the artifact to the next stage. Also, like, make sure that you're creating SBOMs whenever you're creating an artifact. And the thing is, you're also doing your code scan, you're doing your image scans for vulnerabilities, but having an SBOM management system actually really helps, because what's the image scan is happening at the time of building, but what you want is you need to have a way to have a repository of these SBOMs, so that way you know the blast radius in case there's a vulnerability that has been found, right? Now, also at the same time, when you have all these tools in your pipeline, it's a lot of work for the developers. How can you make it easy so that a developer who just joins an organization, like say Hirsch here just joined Capital One, I hear. So how do you know what is Capital One's, you know, security policies? How can he make sure that the code he writes and runs on day one has all these tools, you know, enabled? And so that for that we basically kind of, you know, looked at Backstage. How many of you use Backstage? Anybody familiar with Backstage? No. So Backstage is an you know, like basically internal developer you know, portal. It's an IDP, and so it basically helps you to kind of make sure that everything that the developer needs, the documentation, the source code, the tools that they need to create an application, all that is provided as catalogs, and it's in one pane of glass, one user interface that they will use. So So that's what we have. So backstage is, man, I'm like completely drawing a blank. What is that music? It's on my Spotify. Yeah. Thank you. See, that shows my generation, right? I mean, it's like my daughter actually put Spotify on my cell phone, just because when she's in the car, she wants to make sure that it works. Okay. So as far as S-bombs are concerned, because I'm also conscious of the time, I want to make sure that I can show you a few things in action. So we talked about S-bombs. We also make sure that there is like you do dependency analytics. That means you want to make sure that when you're including a library, you are scanning it for vulnerabilities, and at the same time you're making recommendations as to, hey, by the way, if you're using like say a Java package, make sure that you can use this source because this library has been updated, has been already scanned, and there are no vulnerabilities. And what we'll do is we actually go to the open source vulnerability and the national vulnerability database to actually find out what dependencies have vulnerabilities and make recommendations. And now these are, in this case, Red Hat packages and libraries, and we'll recommend. And I'm going to show it to you very quickly how that works. So for example, I'm in an IDE, right? I'm on my VS Code, and here's my Java application. So if I go to, say, REST Easy package with this blue squiggly, it actually gives me a recommendation, says, hey, by the way, you can switch to this version, and which is more reliable. So this is where the trusted content comes. Now, I purposely put a log4j library which has got vulnerabilities, right? So if I go over there, and it basically tells, hey, there are some known vulnerabilities, like 4 of them, and very, very, very critical. Same thing with struts, right? These are like well known, and once you click it, it'll give you more details. So this, if it can happen at the time of coding, then even before the code goes into the pipeline, you're helping the developer take care of these, help, so that way they are able to substitute the libraries with something that is more recommended by So again, this is in addition to that. Let me go back here. Anybody heard about? Oh, we already asked about GUAC. So we're using GUAC, which is graph for understanding. Well, I'm completely just Google and you'll find out. It is from Google, by the way. So GUAC is, in a sense, nothing but a way to manage S-bombs. So you have relationships, so that way if there is a vulnerability, how many other S-bombs does it affect in your organization. So it is a way to kind of draw that relationship between packages that you're using in your organizations, the vulnerabilities that are there across these packages, and then the different products that are, that have produced S-bombs. So that way, when a vulnerability is known, you can go and use GUAC to make that analysis. So just to give you an idea very, very quickly how it looks, I'm going to go to a screen here. So I can go and look for my S-bombs here that I've uploaded, or in this case, I'm going to just say snappy Java, and I'm going to say search. going to look for some vulnerabilities. I know there's a denial of service attack. Okay, yeah, that's the denial of service attack. So, and there is so it is basically coming from this product, this SBOM, and the dependency is this package, the Snappy Java package. So let's drill down on that particular version of Snappy Java and see what other vulnerabilities are there. And you'll notice that it also has other CVEs that are affecting it, right? And you can also then go and see what are the other packages that are actually using Snappy Java, that particular version, right? So it kind of gives you a full, broad view of all the the software that are being used, and if it is being affected by any of the vulnerabilities. So going back, let's talk about Sigstore. So Sigstore, again, cryptographic signature. It's been there forever, right? You can always use your private PKI keys. What's different about Sigstore is, in addition to supporting private keys, it also supports keyless signing. Because one of the challenges with signing, why don't we always sign our code? Why don't we sign all artifacts? Because it's such a pain to maintain keys, right? And then you lose them, the revocation, all those are pretty hard to manage. So with keyless signing, what you're doing is you're taking that trust away from the key and putting it on your OAuth, your OIDC provider, right? So everybody is either logged into Google or GitHub or your company's single sign-on. So use that identity to sign artifacts. So that way you can then authenticate, hey, this is veda@redhat.com, and then you can have some policies built on that. So on some domain names. So that's the cool part of keyless signing. So suddenly from being a pain for signing artifact, it's so easy. And I'm going to show it to you. I think I still have 5 minutes to go. There is also a ledger. In addition to what does signing do, all it tells you is if things have not been modified. But you also need to have a second source of truth, which is a ledger. So think of your blockchain, but it's not blockchain, it's using Trillion for storing those signature metadata. But so it basically has an immutable ledger which records the whole signature. So I still have 5 minutes, right? Okay, cool. Anybody? So I just want to make sure that I don't step on the next session. Okay. Before we go to enterprise contract, very quickly, I'll show you how that works. So when you set up Sigstore, now Sigstore is available as a public service, so the sigstore.dev, anybody can start using it. Now the only thing is that ledger is maintained in the internet, so all your signatures are going to be public. Now it is fairly easy to set up Sigstore also in-house, and a lot of the major companies, especially financial, they would like to run that Sigstore service in-house, so that the ledger is in-house. The OAuth method that you're using is actually based on your company, single sign-on. And it supports actually many different types of OIDC providers, including Entra ID, which is very popular. That's just Active Directory, right? So once you run the service, basically it runs a certificate authority. It has that ledger. So if you basically set those endpoints, then you basically set up your your OIDC issuer, your root of trust, and Recore, which is your transparency ledger. So you set all that, and then what I'm going to do is I'm going to quickly show you how to create Podman build. So I'm going to, oops. Okay, so I just built a container image, and that's my GUAC registry. This could be any OCI compliant registry, right? And then I'm going to do a podman push. So now when you look at that registry, you refresh it, you'll notice that I just created that container image, and I'm going to do get a gist. And what is a gist? It's basically, so you're not signing using the tag, in this case latest. I'm going to actually use the gist to, and what it has done is basically now it's saying, hey, tell me about your identity, right? So I can either use, so I've set up KeyCloak, which is your Red Hat single sign-on, but I can also use my GitHub identity. So I'm going to just click on GitHub, and I actually already am logged into GitHub, and as you can see, I've successfully signed it. If I go click on the GUAC registry, you should see that there is a .sig file now, which is the signature. And also one more thing that you'll notice is it has made a tlog entry 176, which is that ledger we were talking about. And if you and actually if I go to that ledger and if I look at the index 176, you will see that I've used my email ID to sign it, right? And it also tells you who's the issuer. So you can then simply do a validate. You can say cosign, verify, and then you can say what is the identification. Of course, it takes regular expressions. So you can also use domain name. So here it basically says, hey, I verified the signature on that artifact. Okay. Let me check the time. I know we're 2 minutes over. Is the next speaker here already? Nope. Okay. So if you don't mind, I can show you also, like take another couple of minutes to show you also enterprise contract, because it's a very, very powerful tool. Any questions so far? Oh, there's a gentleman? Okay. Ooh, okay. Instead of showing you a demo, what I'll do is I'll just quickly show you how an enterprise contract looks. So you'll use the same cosign tool to create an attestation. And what happens is, in this case, it's a GitLab build. What I've done is I'm just basically putting the information on what is the build pipeline I use. So I use that identity. What is the, some other information on the URL, the identity. And then you basically use cosign to attest, but use that as a predicate. So once you use that, once you do that, then you can later on do something called as EC validate image, and you can specify a policy. In this case, say my policy is like, hey, make sure that the image actually has a corresponding SBOM. So this particular example, when I ran it, I had things in my, so I not only had my .sig, but I also had the .att for attestation and the SBOM. So it basically makes sure that it is legit and it is verified against the identity. So enterprise contract is just basically an open policy agent, which is written in Rego, and you can basically use that to kind of make sure that the build is valid. We have, if you go to enterprisecontract.dev, right, you'll find a whole bunch of policies like this. So just what you just saw was about, hey, the source code has been included. You'll find all kinds of policies against which you can verify. There are some very interesting blogs which tells you how to use it. So please go ahead and try it. So Sigstore, GUAC, enterprise contract. So go check them out. They're all open source. Okay. Thank you. Sorry, I didn't ask if there are any questions, but I think there are gentlemen waiting. I'll be outside, so you can always